Video, we're going to go over the circular motion notes. So hopefully this will be kind of short. So first up, uniform circular motion is the motion of an object that travels in a circle with a constant or uniform speed. So a lot of rides at like Six Flags and the fair are going to fall in this category. Anything that you just sit and go in a circle for a while, right? So we're going to go through how to calculate the centripetal velocity of the object, the centripetal acceleration, and the centripetal force. So 3 formulas are going to be in this video. So they're all kind of easy, and you're really just plugging in the numbers. So first up, with a centripetal velocity, an object with uniform circular motion is going to have a constant speed. It's going to keep the same speed as it goes around the circle. But it's actually not going to have a constant velocity, because velocity is a vector and it includes both the speed or the magnitude of it and the direction it's going. And as something's going in a circle, it's constantly changing direction. At one point in the circle, it may be going south, one point it's going west, then north, then east, and so on around the circle. So it's constantly changing direction. All right. So it's to find the velocity, you're going to use this formula here in blue, and it's your centripetal velocity is equal to 2 pi r, which is technically the circumference formula, divided by the period, or the time it takes it to go around the circle. Right? Technically, the T stands for period, but we all know it really just stands for time around the circle. Right? But it's one complete lap around the circle. Right? And I'll do an example in a couple slides of this formula. Right? So next up would be calculating the acceleration. So since it doesn't have a constant velocity, it means the object's accelerating because it's always changing direction. Right? So to calculate this acceleration, you're going to use this formula here, which is going to be your velocity squared divided by the radius of the circle. So you're going to take the answer from the previous one, plug it in, square it, and divide it by the radius. Then the last one is going to be the centripetal force. So since it's accelerating, it's going to have an unbalanced forces acting on it. And it's actually going to be, that force is actually going to go in towards the center of the circle. And this, we know this because of Newton's laws. Newton's law says if your object's accelerating, then it's going to have an unbalanced force, right? So to calculate this force, we're going to use the same force formula we've been using, which is F equals ma, where the C's here are just standing for centripetal force and centripetal acceleration, right? So let's go through an example. So we've got our 3 formulas here. We've got a Ferris wheel that has a radius of 40 meters, and it's located in New York City, and it takes the gondolas, which are the things you sit in, 30 seconds to go around the Ferris wheel. So we want to find the uniform speed, or technically, this should say velocity, and then we want to find acceleration, and then we want to find centripetal force, right? So for the first question, we want to find the uniform speed, or the centripetal velocity. We're going to plug in that formula. We're going to take 2 times pi times 40, which is the radius of our Ferris wheel, and divide it by the time it takes it to go around, which is 30 seconds. So we're going to plug that in. I encourage you to type this in your calculator as you're watching the video, and make sure you get 8.38 as your answer. And then the units for this, since it's velocity, are meters per second. Right. Then for the second one, we're finding acceleration. So we're going to take the acceleration formula. We're going to plug in the velocity we just got, and then we're going to square it, and then divide it by the radius, which is 40. So we're going to plug that in. Again, plug it in your calculator. Make sure you get it. Is 1.76, and then it's acceleration, so it's meters per second squared, or meters per second per second. And then the last one is centripetal force on the gondola, and that has a mass of 100 kilograms. So you plug that in, 100 for the mass, 1.76 that you got previously, and you get 176 newtons. Right? Some common mistakes I see in these questions. For the first one, I don't tend to get a lot of mistakes with that one. Most people are pretty good. I would just say be careful making sure you plug in radius and time correctly in the right spots, and don't mix them up. And for the acceleration problem, the most common mistake I see here is people are not squaring the velocity. And then the second thing I see a lot is they plug in time here instead of plugging in radius. So just be careful with that. And then the last one, it's not really a mistake. I just get a lot of questions of like, I don't know the mass, because they think it'll be up here in the main part. And then sometimes people who write the questions will put it down here in this question, like the actual question part. So they just, when they read it, they see, oh, I'm finding this, and then they stop reading and they just don't see the mass. So just make sure you read the full question. All right. All right. Next up, or last thing in this video, is the direction of the vectors. So all of these things, the velocity, acceleration, and force, are all vectors. So they all have direction to them. So we're going to talk about which way they're going. So for velocity vectors, they're going to go outwards from the circle and technically make a 90-degree angle with the acceleration and force vectors. So here in this example, this object's going counterclockwise. And if you follow this green arrow here, it's going around this way. So the red arrows are all going to point out from there like this, like they're shown. If this was moving the opposite way, going clockwise, these red arrows would point the other way. So again, they make like this 90-degree angle with the acceleration and force vectors. And if you picture, like if you had a ball tied to a string and you're spinning it around and then the string were to snap, if it snaps, say right here at this point in the circle, this is the direction that ball would fly off at. All right. For the acceleration and force vectors, they're going to go in the same direction for no matter which way your object's moving, clockwise or counterclockwise. And they're always going to point into the center of the circle. So the force, to make it go in a circle, it has to push inward to keep it in that curve. So they're always going to point towards the center, and they're always going to point the same way. All right, so now let's look at an example. So this object here is going to be traveling clockwise, and so that means it's going to go around this way. And then we want to find these different questions and we're going to pick from these 4 options. All right. So for number 1, it says the velocity vector at point B. Which way is it going to go? So point B is right here. We want to know velocity vector. So velocity is going to go out from the circle at a 90-degree angle from like pointing straight in. So I'm going to drag this down and hover it over. So answer choice A is going to go that way. B is going to go this way. C is going to go that way, and then D is going to go that way. So out of your options, the only one that actually makes a 90-degree angle from going straight to the center is going to be D, all right, which is going to be the correct answer anyway, because it's going to go out from the circle at a 90-degree angle, and it's going to follow the direction it's going. So counterclockwise, in that instance, it's going to point downwards. So that's what we want, all right. For number 2, your acceleration vector at point C. So acceleration and force both go towards the center. So we want to pick one that goes for the center. So at the point C, A doesn't go to the center, B does go to the center. So that's the answer we want. But just to be sure, C does not and D does not. So again, your correct answer would be B, as that points to the center. For number 3, velocity vector at point C. So point C is going to point at a 90-degree angle from the center going in the direction that it moves. So answer choice A does that. But just to be sure, we already know B's acceleration. C goes at a weird angle that we don't want. Oh. And then D goes straight down again. That's not an angle we see. So that leaves us with A, which is the correct answer. All right. And then number 4, acceleration vector at point A. So acceleration again goes towards the center. So the only one that's going to point down here is going to be answer choice D. Is going to go straight to the center. But if you've got questions over any of this, shoot me an email, a message through Canvas, or post it in the discussion page if you need any help with it. All right. See you guys.